little bit of biological fundamentals. In every aerobic wastewater process, there are contaminants in the wastewater. Some are in solid form and some are in soluble form. The solid organic component is dissolved by hydrolyzing bacteria. The solids are converted to dissolved organics, and that dissolved organic feedstock is converted by acidifying bacteria to acetic acid. The acetic acid is the feedstock for the aerobes, which convert the acetic acid to new sludge and to CO2, thereby cleansing the wastewater in the presence of oxygen and the presence of some macronutrients. And at the same time, these aerobes produce enzymes that help in the breakdown of the incoming organic solids. Anaerobic processes are somewhat similar. The first two steps are the same. The hydrolyzing step is the same. Acidification step is the same. And once the acetic acid is formed, it's used by the anaerobes in the absence of oxygen to convert the acetic acid to CO2, methane, and a much smaller portion of new biosolids. Anaerobic systems only produce 10% of the biosolids that an aerobic process produces, and that's very important as I go through this presentation. So our product stimulates the growth and activity of facultative bacteria, aerobes, and anaerobic bacteria. But at the same time, the accelerated activity of these bacteria reduce the activity of sulfur-reducing bacteria through competitive inhibition. So we have a immediate impact on the reduction of odors in wastewater plants at all stages of plant operation. We've done some independent third-party testing, and we have found that the micronutrient Biologic actually increases the respiration rate of aerobes by up to 600%. This is under lab conditions. And we've also found the same thing for anaerobes, that we get a 500% increase in anaerobic activity when our micronutrient is introduced to the biological reactor. In most aerobic systems or activated sludge systems, the bacteria exist in the form of flocks, and the outer surface of the flock is aerobic in nature, while the inner core of the flock is more facultative in nature. And when we hit this flock with our micronutrient, we are stimulating the inner core of that flock, which is normally quite dormant, to take up about 25% of the incoming BOD load and convert that BOD anaerobically rather than aerobically. So we see a 25% drop in oxygen demand in the aeration section of a plant, and we see a 25% to 30% reduction in the formation of new biosolids. At the same time, we see the inhibition of the hydrogen sulfide producing bacteria, so that odors are mitigated throughout the treatment process.